Hi guys, my name is Oluwafemi and I'm a creator of KlayOracle, and in this video I'll be explaining how you can run your own KlayOracle node and how you can make off-chain requests to your smart contract. So, brief context, KlayOracle is a protocol for you to get off-chain data into your smart contracts. So the first thing you want to do is you come to KlayOracle.com, click on this GitHub. Once you come to the GitHub, you clone this repository. Once you clone this repository, which I already have on my PC, I have it open on my IDE Golang. So the first place you come to is you open your KlayOracle, come to adapter. Just to briefly explain, there are three major components that makes up the KlayOracle. There's the adapter where you define like your jobs, right? For example, an example of a job is KlayUSD job, where it gets off-chain data for the price of Klay Klay token in USD, and you have like the CMD, which it's actually for components anyway. You have like the CMD which compiles and you will run to interact with the node, and then you have like the node itself, and then you have the contract here, which is the Oracle contract itself, right? So the first place, like I say, is you come to your adapter, come to like .env here and update these details to match. Like, default here just works basically, where job parties, adapters are jobs, which is where your jobs is situated. Like all of your jobs, you can have as many jobs as possible that you want your node to be watching and to be fulfilling request for. Right here, we have a job for random number, a job to get Klay price in USD, and also, once you have filled this, the key store password here is the password to unlock your node accounts, right? For your node accounts, you will have to create like an account for your node to be able to fulfill those Oracle requests, and then you have to fund it with Klay token. So what's the key store password? Tell it up, and then what's the path? Like this default works, you can change it. That's up to you. So the next thing is you have to build this CMD. So to do that, you just need to run this CMD. Yeah, just run go install.cmd/plug/. Once you do that, that's fine, that works. So for you to see how this works, if you just do COLC help, yeah, that's it. You'll see like the commands are available. You just have version node help. So if I run COC version, yeah, that's it. That's the version that we have. So the next thing is you have to create your account. In this case, if you do clock accounts, clock node accounts, clock node accounts creates, then hit enter. When you run this will like create your node accounts. I already have this anyway, but if you run it twice, it will just tell you like you have an existing account. But now I already have my account. I just need to do clock node account info. And when you generate your account, it gives you address, and you will have to fund it with test token from the faucet, right? In order to be able to fill requests, you have to just fund your token. You have to fund your address. All right. In this case, clock node account info. This bus status happens once a while, where that's why the path status starts like the network doing its thing. All right, let me just review this then. That was fast. Yeah, that's it. Now it shows my balance is 149.98. You can view and explore. That's because I funded this. And no matter how much we run clock node account create, it always give me this single account because that's like the first one that's been created. And you see my balance has been reduced. That's because I've used this like fulfill Oracle requests before. So once you have done this, the next part is for us to actually make like, deploy Oracle and then try to create a contract to get, Clay USD price. So first thing first, I would try to explain how an adapter is structured. For an adapter, you have like, this part of the adapter. The first part is the adapter active. I mean, for these jobs, all the jobs I have here, I only make this job adapter active. Set this one to true. It means that the node while running should load this one. And then the next one is like the name. The name could be anything. The job type, there are two job types. There's data feed and then there's, random number. I mean, right now, they don't matter much, but that's just like explain, but really they don't matter much. Anyway, they are not being used by the protocol right now for this particular version. And adapter ID, this is very important. It has to be unique and it has to be, this length. It has to be unique for every, that must not be the same thing by another adapter. And Oracle, this is the Oracle address. As you would see soon, we are going to deploy an Oracle right here. I mean, the Oracle Smart Contract is the same thing for everybody. You just have to deploy your own, basically. You don't have to change anything for this, right? Because your consumer, like those that will be making use of your Oracle, would actually be referencing the contract address of your Oracle. And a node can run, many jobs and fulfill requests for multiple Oracle. And the most important part of an adapter is the feeds, as you would see here. Now the feeds just mean where are these data going to be like, retrieved from. So in this case, I have like two URLs here that it's getting them from, you see. So for example, to get KlayUSD, you can get it from here. You can pass header and then the request type is get, and then there are reducers that are being run on the feeds. For example, there is this pass reducer, there is a multiply reducer, there are many reducers. If you come to node, come to user.go, you see how all of this work. I mean, the pass reducer is just to, because this returns JSON, it's just going to pass through it and get like a single value, and then this is multiplied. The multiply just because this, what is being returned by the first reducer here pass is decimal, and we have to just multiply this here. And the reason why we have to do that is because we cannot return decimal to the smart contracts, right? And again, this is another feed here. You can have as many feeds as possible. So the node does this thing. It goes through all of these fields, gets all of the data from all of these feeds, and once it gets all of the data, it randomly kind of like selects one. You can go through the protocol to see how it works. So let's get into action. Next thing is we come here. There's the Klaytn IDE for Remix. Come to contracts, the Oracle right here. Save, and let's deploy this. I already have Klaytn Baobab added to my MetaMask, and I can deploy. I already have some text font from Facets, so I can deploy my Oracle right here now. So to deploy my Oracle, I need to pass this. I need to pass my node address and the adapter ID. So in that case, if I come here, we already have a node here created. Yep. And then what's the adapter that this Oracle is handling? In that case, this Oracle is simply handling this single job, right? And this is the adapter for the job, which is this. So I come here, I click on this and do this, and of course do this and transact. Okay, I've now injected cancel, inject web3. Nope. Let me just reload this then, so that my MetaMask can be injected here. I mean, does this once a while. Alright. Yeah. Oracle. Save. Inject the web TV. Yep, that's because I've connected it before to my MetaMask, so that's no problem. And just open MetaMask. Let's see. Here I have this here. So what I will do right here is to deploy, I need to pass my node address and my data ID. So my node address, I come here, and here is my node address again. Pass node address, and for adapter ID again, let's see, yeah, we said it has to be unique, it has to be a string, and it has to be this particular length here. So we come here, we enter this and transact. So it pops up and confirm. Right, this is deployed. Right, say, oh, what's my adapter ID? See, what's my node address? See. Alright, so the next step again is to like deploy a consumer, right? Which if you come here and click on price consumer. Alright, so to explain how the price consumer contract works, which is could be any of your DeFi smart contract, whatever smart contract it is that you're trying to get Clay USD price into in order to really use. What you would do is have like your whatever function, your smart contracts that is doing some stuff, and at some point in time wants to make a request to the Oracle. So you import your Oracle, you do here. In this case, I'm just going to pass like the Oracle address here. You could have it uploaded to your smart contract. I mean, we already deployed Oracle and then the adapter ID. Those are the two things that I needed: the Oracle address and adapter ID, right? So here I would make like call new Oracle request here, and very important, you have to pass selector. This selector here is going to be the function that the Oracle will call back and pass the results to. Okay, and then the adapter ID and then address of the smart contracts, right? So that's it basically. So let's just deploy this and make sure you do this to be able to be sure that it's only the Oracle that you are using that will be able to call you back. All right, you don't want another Oracle to call you back anyway in this case. So I will save this again. It's going to compile it. Once I do command save, I really like how this Klaytn editor works. Just like run the compile right here, and then I can deploy this. This is our Oracle here, deploy price consumer. Let me just try again. Yeah, I know I've compiled it, so yeah, and come to deploy. Deploy. All right, Oracle address. So we just have to now do this. Now we need to have to request Clay price. We need to pass our Oracle address here, which we have here. Adapter ID. What's our adapter ID again? Yeah, it's really the same as this anyway. All right. So now that we have our Oracle here, let's get back to adapter that we have here. We need to update our Oracle here to this. Yeah, this is the Oracle. Just to confirm. Yes, this is our Oracle that we just deployed here. Was this very important? Yeah, it's correct. And we see our adapter ID here. No. yeah, it's all correct, to be honest. So yeah, just trying to confirm. Now, the next thing you have to do is you need to start running your node to run watch, right? So like we have the other time, we said node, if we do help, so we clock node run watch. You'll see it says loading job at this directory, reading Clay adapter, loaded Clay USD with is active, the rest false, so it's not loading them, so it ignores them, listening to Oracle at 0cc. Alright, so we are just going to head back to our price consumer and click on transacts. We'll fill in the Oracle address in here and the adapter ID, click on transacts. MetaMask will pop up and we approve that request. This is like a consumer smart contract. We click on confirm and we made it come back here. See, request ID, this response for Oracle. I'll explain this shortly anyway. There's a last step that is going to take. Yeah. So you see what just happened here is, all this logging happens, so to help you understand, right? Which is it runs the passing on all of these. A response, it runs the reducer pass, and the result is raw, Clay, all of this stuff. And after running through like all of the two response, then it does this, multiplying 1E09 to it, and this is what it does. Same thing applies to the second URL. Like the second URL also returns this, then it runs pass through it. You just run it once, which is just getting rates. I mean, if you look here, that's it. It just comes here and get rates, But for the other one, just work. And after doing that, the next thing is it does multiplication, which then gives this. And these are the two that have been returned, and randomly select one, which is the best. Select the first one, and then it calls out at Oracle with this. It calls at Oracle with this response, which is like it's going to get hexadecimal value and return and that one. So if I come back here now and come here and click on price, see, yeah, that's the price. And then we can just divide it by one exponential 9 to get the original price, because we can't do decimal. So that's how it works. If you also want to do the same, you can do the same for random numbers. You can try all of this out. Have an issue, create an issue on GitHub and let me know what's up. Alright, thanks guys. And if you start using this on your project, I would also like to know.